All right, so every software engineer runs into this classic problem. You know the one, a user kicks off some long-running job, like a massive data export, and the system has to go chew on that in the background. The real question is, how do you actually tell the user when it's finished? Well, today, we're going to break down two really popular ways to solve this, the classic polling approach versus the more modern WebSockets. Let's dive in.
So let's just set the stage a little. Picture a user in your app. They need to export a huge data set. We're talking something like 5 gigabytes from a data warehouse. They click that export button and, well, that's not going to happen instantly, right? The backend takes the request and starts processing it asynchronously, which is great because the user isn't just stuck looking at a frozen screen.
And this is the core of our problem today. The backend is off in the corner, churning away, getting that secure download link ready. But the user's browser, it's just waiting. It has no idea what's going on. So how does the front end finally get the message that the job is done and the file is ready to go? That's the technical challenge we're going to tackle.
Okay, first up we have our first contender, client-side polling. Now this is a super common, really straightforward method. It's easy to wrap your head around because it relies on the same request-response model that pretty much the entire web is built on. It's often the go-to for a lot of developers for that very reason.
So what is HTTP polling exactly? Well, think of it like the client, the user's browser, taking all the initiative. It just repeatedly sends a request to the server, basically asking over and over and over again, are we there yet? How about now? Is it done yet? And it keeps doing that until the server finally has something new to report.
And this slide right here, it perfectly illustrates what's sometimes called the polling trap. Look at the loop. The client sends a request asking for the job status. The server just says, nope, still processing. Then the client has to wait for a fixed amount of time, let's say 30 seconds, and then it asks the exact same question again. This loop just keeps going, creating traffic, until finally one of those requests gets the magic completed response.
And that really brings us to the key takeaway for this method. The biggest thing Pollen has going for it is its simplicity. I mean, it's just standard stateless HTTP. It's easy to build, easy to debug, but the trade-off, and it's a big one, is that it's noisy. It creates so much unnecessary network traffic, and most of those requests are just getting back the same old still processing message.
Okay, so let's check out our second approach, which builds a totally different kind of communication channel. Instead of the client constantly having to ask for updates, what if the server could just tell the client when the job is done? Well, that's exactly what WebSockets were designed for, real-time, two-way communication.
And you don't have to take my word for it. This quote from the actual WebSockets specification spells it out perfectly. The whole point of this technology was to solve the exact problem of polling, that need to open up connection after connection just to check for updates. Instead, you get one single persistent channel to talk back and forth.
And this shows just how different the flow is. It all starts with a regular HTTP request, but it's got this special upgrade header. The server sees that, says OK, and basically the connection transforms from HTTP into a WebSocket. And now it's a two-way street. The client just sits back and listens. It doesn't have to do anything else. And when the backend job is finally done, the server proactively pushes the completed status right down that open connection. No asking required.
So, the one-liner for WebSockets is basically the exact opposite of polling. They are incredibly efficient. Once you get past that initial handshake, the overhead is super low, and you get updates instantly. But all that efficiency comes at a cost, and that cost is complexity. These connections are stateful, meaning your server has to keep track of every single one, and you have to build your own logic for things like what happens if a connection drops.
Okay, so we've seen how both of these work in theory. Now, for the fun part, let's put them side by side and really compare them across some key engineering criteria and see where each one truly shines, or doesn't.
This table really breaks it all down, doesn't it? Let's walk through it. For complexity, polling is just low. It's plain old HTTP. WebSockets, though, high. You're managing a persistent, stateful connection, and that's a whole different beast. For scalability, polling's stateless nature makes it a breeze to scale with standard load balancers. WebSockets are much harder, often needing sticky sessions to make sure a user stays connected to the same server. Reliability? Retrying a failed HTTP request is simple. Handling a dropped WebSocket, that requires custom logic you have to write. But now, look at user experience. Polling always has a delay, but WebSockets are instant. And finally, resource usage. Polling is high, creating all that chatty traffic, while WebSockets are super efficient.
So, after weighing all of those trade-offs, which approach should we actually choose for our specific problem, that big infrequent data export. Let's get to a final verdict. But before we declare a winner for our use case, let's just boil it down to the fundamental trade-off. It really comes down to this: what do you value more? Is it the simplicity and the robust stateless architecture you get with polling, or do you absolutely need the raw efficiency and the instant real-time updates that WebSockets give you?
All right, here's our final recommendation. For this specific scenario, a large job that doesn't happen all that often, the pragmatic choice is actually polling. So, why? First, the latency is totally acceptable. I mean, if a job takes 5 or 10 minutes to run, is a 30-second delay in the notification really a bad user experience? Probably not. Second, it has way less implementation overhead. You get to avoid all the complexity of a WebSocket setup for what might be a non-critical feature. Third, your infrastructure stays simple. And finally, and this is a really key engineering principle, it helps you avoid premature optimization. Yeah, polling is noisy, but for a feature that isn't used constantly, the actual resource cost is tiny. It's just not worth the massive engineering effort to eliminate it.
So the real takeaway here isn't that one of these is always better. It's that the context is everything. You always have to be aware of the trade-off you're making. So for your next feature, ask yourself this simple question: what is more important right now? Is it the speed of getting a simple, reliable solution out the door? Or is it the long-term resource efficiency of a more complex, real-time approach? Asking that question will almost always guide you to the right answer for your project. And that's our look at the very real, very practical trade-offs between polling and WebSockets.